All right, let's have a look at Check Your Learning 9.1, page 253 of the New Century Physics for Queensland, Units 1 and 2. I'm looking at question number 3. I'll just apologise in advance. My hands are a bit messy from gardening all holidays, and I've got hay fever today, so I'm a bit snuffly. So the heavy breathing is not because physics is so exciting, it's because pollen is annoying. I've got Albert here for moral support if we get stuck, but this one's a bit trickier than the last one. I've had a practice look, so I think we'll be right. Okay, so we've got 8-volt battery coming along. We've got parallel part here in our circuit, another resistor here. In the example before, these two resistors were the same size, which makes it a bit easier. But this time the current will split, and it will split unevenly. The bulk of the current is going to choose the easy path, and it's going to go through the 3 ohm resistor, but some of the current is still going to go through the 9 ohm resistor. The example this time has got the conventional current marked in, so that actually goes from positive round to negative, even though we know electrons form a current and it goes the other way. But conventional current is always drawn in from positive. Positive, I remember, is always the longer one because it would take me like 2 sticks to draw a positive sign. So I'd need that much ink for a positive and only that much ink for a negative. And that's how I remember it. Okay. Radio. So first step again is going to be to replace this part of the circuit, the parallel part, with a single equivalent resistance. That's going to let me work out a few more things. So I want this part, and I'm going to work out the resistance is in parallel. So it's going to be using this rule here. So I'll have 1 on 9 plus 1 on 3. That's 4 on 9, or you can just do it in your calculator. And when you do, you will find you have to get the reciprocal of that. So R will be 9 over 4, which is 2.25. So I can replace, 2.25. I can replace this part here with a single 2.25 ohm resistor. So I'm also wanting to know what the total resistance would be now. So I can just quickly draw up. I've got 6, and I've got this one, 2.25. So the total resistance in a series, which is what we've got here, this is series, is just R1 plus R2. So we have got 6 plus 2.25, 8.25. Right, so I can use that now to find out what the total amount of current that's allowed to flow in this circuit is. The total resistance determines how much current can flow. So I use Ohm's law for that. V equals IR. I is going to be V divided by R. So we've got 8 divided by 8.25, which is 0.97 amps. So that's the amount of current that can flow through this circuit. So that actually will be this one here. It's going to be 0.97 amps. Okay. That current, when it comes here, is going to split. And it's going to split in the ratio of 3:1 because this has 3 times more resistance than this. Right, so if you think back to when you did ratios and things, if you've got 3:1, then you actually need 4 shares. I'm going to show you 2 different ways to work out the current here. One's a super quick way, but you kind of have to have You just have to understand how ratios work. The other way, we'll use a bit of Ohm's law magic. Okay, so the first way to do it is to say it's 9 ohms is to 3 ohms. So it's 3 is to 1. So our current is going to split up according to this ratio, but inversely. So this one is only going to get 1 share of the current, and this one is going to get 3 shares of the current. We need 4 shares in total. So if you think about, so there's 4 shares in the current, and the total current was 0.97. So we've got 0.97 divided by 4 equals, where did I work that out before? 0.24. So 0.24 is going to go through the 9. So I know straight away this one is going to be 0.24 amps. And 3 times that amount will go through the 3 ohm resistor, because this has got 3 times more resistance than that. So 3 times 0.24 is 0.72. Right, so 1 share is going to be going through the 9 ohm. It gets 1 share of the current. So it's going to be 0.24 amps. The 3 ohm resistor is going to get 3 shares. So it gets 0.72 amps. Now, as a check, these two should add to what the total current was, because it was the total current that got split. But that adds to 0.96. So it's not quite perfect because I dropped off some decimal places here. So if I had kept those decimal places in, this would have added up to 0.97. But this is accurate enough, so that's fine. That's a simple, quick, just an inspection method, more or less, of doing it. The other way is a little bit more difficult. So in it, we need to look at our resistance here and our voltage there and work out, we've got our resistance here. We know that the total current is 0.97. So what I want to know is how much of the voltage gets used up in here. Because remember, the voltage drop is the same across each arm. So if I know that voltage drop across there, then I can work out the current in each arm. So we have got and there's a 6 ohm resistor here. So let's start with it. So this one, if we go V equals IR, this resistor here is going to use up, and all of the current flows through it because it splits up and it all comes back together. So it's 0.97 times 6, 5.82. Okay. So 5.82 volts of the 8 volts from the battery is going to be used up going through this resistance here. And that actually gives us the answer to the question where it says, what's X? So the voltage here is 5.82 because the voltage on this side is supposed to be 0. So it's 5.82 here. 5.82 volts gets used up going through here. That means 8 minus 5.82 volts is going to be used up in this parallel bit. So the voltage in the parallel part is going to be 8 minus 5.82. It's 2.18. Right, so if we look at the 9 ohm resistor then, And we know that the voltage drop across that arm is 2.18, and V equals IR. I equals 2.18 divided by 9, which is 0.24, which is excellent because that's what we worked out over here, so that's correct. And you can either take 0.24 off the total current, or if you really love Ohm's law, you can do the same thing for the 3 ohm resistor, and you would get the current is 2.18 divided by 3, which is 0.72. Right, and again, these two theoretically should add to give us our 0.97. We'll have lost some things in decimal places, so that's pretty close. That's a good check. Check that your total current is equal to the current from the two parts. So that gives us all of the answers that we required. We needed this current, we needed the current through the 9 ohm, we need the current through the 3 ohm resistor, and we wanted the voltage here, so the voltage drop across the 6. So we've done all of that. There you go.